Welcome to today's edition of Geometry. Today we're going to discuss angle measure. It's weird how fishing is called angling, huh? So the first thing we're going to talk about is how we measure and classify angles. But to do that, we have to understand what some of the parts of an angle are. Now, one of the parts of an angle is a ray. A ray is a part of a line. It has one endpoint and extends indefinitely in one direction. Rays are named by stating the endpoint first and then any other point on the ray. So here we have a diagram of what we would call ray ST. We can see here that this endpoint that we have on this ray is S. That's the endpoint. We are extending this ray out through point T. Notice that the symbol is a ray. It's just an arrow in one direction, right? And one of the things you need to also notice is the first letter is the end point. Okay, so if we have a line, all right, and we choose a point on the line, in this case we would be choosing, let's say, point J. Well, there are two rays that go in opposite directions, right? So we can take a look here and we would have, this would be a ray going this way, and then we'd have another ray going this way. So the way we would name these two rays on this side, right, that would be ray JH. Over here, this would be ray JK. We always do it to the right, from right to left. Okay, so it doesn't matter if the ray is pointing to the left. We name it always pointing from right to left to right, I should say. We read from left to right. So we name the endpoint first, in this case J, and then H. Okay. Now, one of the things that we might have happen, let's say, are these opposite rays. Whoop, that's not what I wanted to do. I wanted to erase all this. Okay. And let's say we have a ray starting at K. So we have ray KJ or KH, right? And then we would have this ray here, okay? These are not opposite rays, okay? Okay, they've got to have the same exact endpoint, okay? So we would say down here, this is ray KJ or ray KH. Either name is right for that ray, okay? Over here we have ray HJ or ray HK. You'll notice the first letters are not identical, therefore they're not opposite rays. They don't go on the same line, all right? They'd have to be collinear and have the same endpoint to be opposite rays. Okay, so now an angle is formed by two non-collinear rays that have a common endpoint. The rays are called the sides of the angle. The common endpoint is called the vertex. So if you can see here in this drawing, we have this side ray XY, and we have side ray XZ. And the vertex is that common point there, that common endpoint of the two rays, and that is called, and that would be point X. Okay, so the vertex we just name with a single letter. Okay, so now when we name angles, we use three letters. Okay, the second letter in the angle name must be the vertex. You can only name an angle with a single letter when there's exactly one angle located at the vertex. Okay, so let's take a look at our diagram here, and what we can see with this diagram is we have the vertex is X, right? So the vertex must always be in the middle. We only have one angle in the picture, right? So we could call this angle X, like we see here, right? We see angle X right here. Okay. We would, if there was more than one angle in the picture, we would call this angle YXZ or angle ZXY. If the diagram has a number here, okay, that's not a degree measurement. A degree measurement is going to look different than that. This is a name for this angle. That's angle 3. Okay. So we have a number of ways we can name angles when there's only one, or if it's numbered, or if it's got the three letters. Sometimes and it always will change depending upon the diagram. So you have to know you're always safe by naming with three letters. Okay. So now, if we're in the plane with an angle, okay, we're on a plane, it divides the angle into three very distinct parts. So the first part is right here on the line, okay? So if we are on this line, as we can see here, points Q, M, and N are on the angle, okay? As you can see here, they're on that red angle, okay? Now, this part here, this is the interior, okay? This part here is called the exterior, this part out here. Okay. Time for some example problems. Okay, we want to name an angle that has B as its vertex from this diagram here. So, take a look at it, find point B, right, which would be right here. There's point B. And name at least one angle, and we'll come back here in a moment, and I will share with you all of the angle names that are possible. Go to work. All right, so let's discuss this. So I have in this diagram, here's point B, all right, circled. Well, I've got a number of angles. I have an angle right here, right? This one right here. And I have this angle right here, right? So we could name this we could have a couple of different names for this angle, these two angles. Let's go with angle number one. Angle number one, we would also call angle ABD and angle DBA. The letters can be switched, and as long as B is in the middle, it's correct. Okay. So in looking at this next angle, we would say that would be angle 2, right? So angle 2 is another angle. That angle also would be called angle CBD or angle DBC. We probably would not go with a angle with K or L because it looks like this angle at C kind of opens up. It's not a straight line. It doesn't appear to be straight. It looks like it's bent a little bit. So that would not continue on a straight line. Okay. Okay, name the sides of angle 3. Go ahead and see what you can do with this. Remember, what are the sides of an angle? They are rays. Use that knowledge, right? Oh, so here's angle 3 right here. This would be angle 3. So go to work. All right. Now, sides of angle 3. Well, we can take a look at this and let's see if I can get this to show up here. There's this ray here, right, is one of the sides. Okay, let's use a different. I'm trying to find something that shows up. Nothing's wanting to show up on this diagram. Anyway, so there's this side right here, right? That's not doing it either. There's one side, and here's my other side of that angle. Okay, so let's go to the first side here. I can call that side ray CB or ray CA. The other side of the angle is ray CE. Okay, so any one of those first two are correct. The other one is by itself, and that's ray CE. Okay, what's another name for angle GHL? So we go to G first, and then we go down to H, and then we go to L. So that's this angle right here. Go ahead and see if you can come up with another name for angle GHL. All right. So names we could use. Well, the most obvious one and the easiest one is that numbered angle there, angle 7. We can also reverse our letter length, our letter positions, right? So that would be angle LHG. Both of those would be correct. All right, name a point in the interior of angle DBK. So angle DBK, angle D starts here, and it goes to B, and then it comes out here to K. So there's our rays right here. Go ahead and answer that question. All right. So, well, there's only one answer. This is the interior. Here's the angle, right? And there's only one point that's in there, right? So our point here would be just point E. Weird looking E. I didn't like it. Okay, let's move on. Okay, so angles are measured in units called degrees. The degrees result in dividing the distance around a circle into 360 equal parts. Okay, so we can look on this diagram here, and we can see there are 3 different angles and how they are classified. So right angle always has a measurement of 90 degrees. Okay. An acute angle always has a measurement less than 90. Okay. An obtuse angle is between 90 and 180 degrees. So angles that we would classify by their measurements, a right angle is 90, an acute angle is less than 90, an obtuse angle is greater than 90. So one of the ways maybe you can remember this is if an angle is smaller than 90, right? Small things tend to be cute, right? So acute, right? Obtuse is close to the word obese, which means fat, right? So obtuse angle would be a fat angle, it'd be bigger than 90. Okay, so those are the 3 classifications we have right now. Time for even more example problems. All right, so what type of angle is angle MJK? Right, so MJK starts here, goes down to here, and then it works its way out. Well, we can look at this, and one of the things we can deduce is that since this measurement here, okay, all the way from here to here is 180 degrees, right? Because the shape I sort of drew here is a semicircle. It's halfway, right? It's a halfway circle. It's half of a circle, okay? So that angle measurement is 180 degrees. Well, I can see that this angle here is 90. If this one is 90, then angle MJK is also 90. We can figure that out by deduction. So, what kind of angle is angle MJK? It is a right angle. Angle LJP. So that one is from here to here to here. Well, there it is to there, right? So this angle measurement right here. Well, if this is 90 here, right, this is 90 degrees right here, and I've got this little section over here, this angle is definitely more than 90, so this would be an obtuse angle. Angle NJP. All right, so we're going from angle here, we're coming down here, and then we're coming out to here, right? So that's this smaller angle here. Well, we can see that here's the right angle. This angle here is way smaller than this angle right here. So this would be an acute angle. Okay, what type of angle is angle KJP? Well, what we would call this angle, it is a straight line, right? We have a straight line running all the way here, right? So since it's part of a straight line, we call this a straight angle. And it always equals 180 degrees, right? Okay, let's talk about congruent angles. Okay, angles that have the same measurement are congruent. And when we mark congruent angles, we look at them and we give the same identical marking. Okay, so you can see here that this 65-degree angle has this mark, as does this 65-degree angle. Okay. Angle CBE, which is this one right here, angle CBE, and angle DEB, okay, they have the same markings. Now, how would we know that those two angles are congruent? Well, we can look at this and we can say, hey, since this whole thing is 180 degrees, right? To figure out what angle CBE is equal to, I would say that, so angle CBE is equal to 180 minus 65. So angle CBE is equal to 115 degrees. I can do the same thing with angle DBE, or excuse me, angle DEB. Angle DEB is also 180 minus 65, and we figured out, hey, by doing a little bit of subtraction, angle DEB is equal to 115. Well, what's the rule? The rule is that if they have the same measurement, well, they both have the same measurement, therefore they have the same markings. Okay. If a ray divides an angle into two congruent angles, we can look on this diagram, we can see that this angle is 80, this one's angle 80, they're right next to each other there. That is called an angle bisector. So we would say that ray YW is an angle bisector. We could also say ray YW, or excuse me, yeah, YW bisects, cuts into two congruent angles. This bigger angle here is cut into two equal angles. So we would say that it bisects angle X, Y, Z. Okay, so just as with segments, when a line segment or ray divides an angle into smaller angles, the sum of the measure of the smaller angles equals the measure of the larger angle. One of the things I tell students to do is just to label things. So we might say that this is a smaller angle, this is a small angle, and we might say this is the medium, but that's equal to the large. Okay? So the smaller angle plus the medium angle equals the large angle. Last example problem. So in this figure, ray KJ and ray KM are opposite rays. And ray KN bisects angle JKL. If the measure of angle JKN is equal to 8x minus 13 and the measure of angle NKL equals 6x plus 11, find the measure of angle JKN. Okay. So first thing we do is we always mark the diagram. We take information from the problem. So opposite rays, all right, KM and KJ. KN bisects angle JKL. So angle JKL is cut, and this angle is equal to this angle. All right, so it says then angle JKN, so this angle is equal to 8x minus 13. Angle NKL is equal to 6x plus 11. Right? We want to find the measurement of this angle here. We want to find that angle value. So now we need to do some math and set up an equation, right? So the first thing I know by the diagram, when something's bisected, I get two equal angles. So I'm going to make those two angles. I'm going to take this one here, and I'm going to take this one here. I'm going to make those two equal. So I'm going to say that 8x minus 13 is equal to 6x plus 11. I'm going to go ahead and get all my x's to the left. So I'm going to subtract 6x from each side, and I end up with 2x minus 13 is equal to 11. From here, I add 13 to each side of my equation, and I end up with 2x is equal to 24. I would divide then my two sides of my equation by 2 and end up with x is equal to 12. So now I take 12 and I plug it back in. So angle JKN is what we're looking for, right? So the measure of angle JKN is equal to 8x minus 13. I take x out and I put in 12. So 8 times 12 minus 13. 8 times 12 is 96 minus 13. So 96 minus 13 is 83. So the measure of angle is equal to 83. Always circle your work. This way your teacher, whoever's grading it, can find your answer.